Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope has just made a staggering discovery, one that could change everything we thought we knew about the cosmos. New evidence suggests that our universe might not be alone. In fact, scientists now believe that during its infancy, our universe may have collided with another, leaving behind strange and unexplained clues in the fabric of spacetime. These findings have astronomers questioning some of the most fundamental theories about how our universe evolved. Webb's ultra-powerful infrared vision has allowed it to peer farther back in time than ever before, uncovering ancient, bizarre galaxies that seem impossibly massive and bright for their age. According to current models, galaxies in the early universe should be small and developing, yet Webb has revealed structures that are fully formed and far larger than expected, a direct contradiction to what theoretical physics predicted. This discovery is forcing scientists to reconsider our entire understanding of cosmic evolution. But the surprises don't stop there. Humanity has long pondered a fundamental question: does the universe have an edge, or does it extend forever? Based on the standard model of cosmology, the universe began about 13.8 billion years ago with the Big Bang, and from that point, physicists built models to explain its growth and expansion. However, Webb's revolutionary findings are now shaking the very foundations of these long-standing beliefs. Could the cosmos be far stranger and more complex than we ever imagined? With each new discovery, the James Webb Space Telescope is rewriting the story of our universe. As we continue to explore deeper into space, we may be on the brink of answering some of the most profound cosmic mysteries or uncovering entirely new ones. Until now, we assumed the universe had a clear beginning and has been expanding ever since. But what if that's not the full story? Some scientists are now questioning whether the universe had a conventional start at all, or if its earliest days were something entirely different. At the 2024 International Space Science Institute Breakthrough Workshop in Bern, Switzerland, experts gathered to analyze Webb's data in a study titled "The First Billion Years According to the James Webb Telescope." They focused on the universe's first billion years after the Big Bang, a time when galaxies were forming, stars were lighting up, and black holes were growing in mass. And what they found is rewriting the history of our cosmos. Peering into the early universe requires cutting-edge telescopes, and the James Webb Space Telescope is pushing the limits like never before. While Hubble could observe galaxies with redshifts up to 11, Webb has shattered that record, reaching an astonishing redshift of 14.32. What's even more mind-blowing? These ancient galaxies formed during the cosmic dawn are far bigger and brighter than scientists ever expected. Take JWST 14, for example. This galaxy, spotted just 300 million years after the Big Bang, contains several hundred million solar masses. That raises a huge question: how did something this massive and luminous form so quickly in the early universe? Current models can't fully explain it. But the surprises don't stop there. Astronomers have detected carbon in a galaxy that existed just 350 million years after the Big Bang, hinting that the building blocks of life may have been around almost from the very beginning. Even more astonishing, the presence of oxygen in this early galaxy suggests that multiple generations of massive stars had already lived and died by this time. That means star formation and cosmic evolution may have been happening at a much faster pace than we ever thought. Based on what we've seen so far, scientists believe Webb may soon observe galaxies at redshifts of 20, reaching back to a time when the universe was just a few 100 million years old. But here's where things get really wild. If Webb detects galaxies even older than that, it could shake the very foundation of our understanding of how galaxies form. According to the standard cosmological model, the universe went through a phase known as the Dark Ages, a time after the Big Bang when space was filled with neutral hydrogen gas, making it completely opaque and devoid of stars or galaxies. Theoretically, nothing should be visible beyond this point. But what if Webb finds something beyond the Dark Ages? Did the James Webb Space Telescope just break our understanding of the universe? New images from Webb have revealed something truly shocking: galaxies that appear to exist before the Dark Ages. This is a massive problem for conventional cosmology because, according to our current models, there shouldn't be any galaxies before this period. Even stranger, these ancient galaxies don't look anything like what scientists expected from the early universe. So what's going on? Are we seeing something entirely different, a separate universe perhaps? And why do we keep finding massive, mature galaxies the deeper we look? According to modern physics, if we rewind time, we should see smaller, younger galaxies, eventually reaching a point where no stars or galaxies exist at all. Instead, Webb is uncovering enormous, well-formed galaxies at times when they shouldn't have existed. Could this mean that the early universe was governed by completely different physical laws? But the mysteries don't end there. A recent study published in the Journal of Cosmology and Astroparticle Physics suggests that gravity itself might have been weaker by about 1% on cosmic scales in the early universe. Scientists reached this conclusion after analyzing the cosmic microwave background, the faint radiation left over from the Big Bang. When they applied Einstein's theory of gravity, their models didn't quite match the observed data. But when they tweaked gravity to be slightly weaker, everything lined up. This hints at something revolutionary: Einstein's laws, which work so well for the nearby universe, may need modifications when applied to the cosmos's earliest moments. And if that wasn't enough, Webb's observations have also deepened one of the biggest mysteries in cosmology: the expansion rate of the universe. Different methods of measuring this rate keep producing conflicting results, even though they've all been verified as accurate. This suggests something unsettling: dark energy, the mysterious force driving cosmic expansion, may not actually be constant. Instead, its strength could be changing across different parts of the universe. One fascinating idea suggests that during the universe's rapid expansion, it may have interacted with a neighboring universe. According to the multiverse hypothesis, our universe might not be alone. It could have formed right next to another one. And if they collided, that impact could explain why the laws of physics seem inconsistent across different regions. Imagine if the northern and southern parts of the cosmos were governed by entirely different rules. This might also explain why Webb keeps finding massive, mature galaxies just a few 100 million years after the Big Bang, something our current models struggle to account for. If a cosmic collision occurred early on, it could have altered the fundamental structure of the universe in ways we're only now beginning to uncover. These unexpected discoveries are forcing scientists to rethink everything we thought we knew about the early cosmos. Is there a massive flaw in our understanding, or are we glimpsing physics beyond our current grasp? And that's it. The universe just keeps surprising us. Could we be living in a cosmos shaped by another? As we push the boundaries of discovery, one thing is clear: our understanding is only beginning. Stay curious, stay inspired, and keep exploring with Spaceverse. Until next time, the universe awaits.